I am Mohammed Abdul Karim. This slide is a follow-up to our previous slide. My fish are dying. This time around, it is screaming fishers. Acidity refers to the capacity of the water to donate hydrogen ions. These include unionized portion of the weak acid, carbonic acid, and tannic acid, as well as ferrous/aluminium sulfate, that is alum or gypsum. Fish are able to live in water within a range of about 3.5 to 10 pH. 3.5 here, the water is acidic, while 10 is alkaline. But the desirable range for most fish is from 6.5 to 9.0, that is slightly acidic and slightly alkaline. Many tropical fish require acid waters for breeding and larval development. Fish have less tolerance of pH extreme, especially catfish, at higher temperatures. When temperature is high and the pH is below 3 or above 10, it becomes much more problem to fish. Ammonium toxicity becomes an issue at higher pH, and hydrogen sulfide is more toxic at low pH. When we say ammonia, it means total ammonium plus unionized ammonium. The relative proportion of ammonia and ammonium ion present in the water is merely affected by pH. When pH is high, unionized ammonia predominates the water. But when pH is low, ionized ammonia predominates the water, with less than 10% of ammonia in the toxic form. But when pH is 8, this proportion increases dramatically as pH increases. The amount of ammonia will increase much more when the pH is about 8.0. The pH of pond is influenced by the amount of carbon dioxide present. Much of this carbon dioxide present in the water is the result of animal and plant respiration. This compound, carbon dioxide, is very useful in the water body. It improves or enhances the ability of the water to resist fluctuation of pH. That means it acts as buffering capacity of the water body. Since carbon dioxide in the water is acidic substance, the pH of the water is usually highest, that's in alkaline, in the late afternoon, when there is no photosynthesis, enough production of dissolved oxygen and removal of carbon dioxide in the water, the pH will tend to be high in the late afternoon. And lowest before sunrise. That is acidic, because there is no sunlight to enable this oxygenating plant to photosynthesize. Accurate measurement of daily changes in pH of pond should be sampled during early morning. At that time the pH is low, acidic, and late afternoon when the pH is moving toward alkaline dead point of fish. The amount of the daily fluctuation is somehow dependent upon the buffering capacity of the water. Adding agricultural lime to the pond increases the bicarbonate buffering capacity of the water. Hydrogen sulfide is a colorless, odorless compound. It is a toxic gas with odor similar to rotting eggs. Hydrogen sulfide kills fish by interfering with the respiration. When fish is first exposed to hydrogen sulfide, there will be an increase in gilling rate. Later, the gilling rate slows, and finally respiration ceases. Hydrogen sulfide is present in the water from wells located in certain locations, and it is also present in a pond as a result of bacterial decomposition of organic matter. When organic matter decomposes, it releases hydrogen sulfide. Hydrogen sulfide is more toxic to fish at low pH because greater percentage of this hydrogen sulfide is on unionized state. Raising the pH by liming can result in increased survival of fish. High temperature greatly increase the toxicity of hydrogen sulfide. Addition of 2 to 6 parts per million, 2 to 6 milligram per liter of potassium permanganate can rapidly alleviate the problem. If you add 2 to 6 parts per million of potassium permanganate in the water, it can reduce the problems of hydrogen sulfide. If the pH is low, this toxicity of hydrogen sulfide can be reduced by addition of limestone. Alkalinity and hardness are similar, but they represent different types of measurement. Alkalinity refers to the capacity of the water to accept hydrogen ions and is the direct counterpart of acidity. If you remember what our chemistry start used to tell us, originally The hardness of any water was the measure of the capacity of the water to precipitate cheaply calcium and magnesium ion. That is what we have been told, and it is still correct. But may also be precipitated by divalent ions and other metals such as aluminium ion, manganese, zinc, and hydrogen ions. The anion or bases involved are merely carbonate, bicarbonate, and hydroxide. Adding agricultural lime to ponds increase the bicarbonate buffering capacity of the water to resist fluctuation of pH in the water. Ammonia is excreted as a result of protein metabolism. Some of these ammonia reacts with water to produce ammonia ions, and the remainder is present as unionized ammonia NH3 to fish. The ammonium ion, the unionized ammonias, can be lumped together as total ammonia. Is the source of nitrogen in the water. As earlier mentioned, nitrogens can be harmful, even a small amount, to the fish, especially when it is in the form of nitrite. They interfere with the blood chemistry. They change the color of the blood, hemoglobin to methemoglobin, which is incapable of taking dissolved oxygen present in the water. The fraction of ammonia that is unionized varies with salinity, dissolved oxygen, and temperature. But it is primarily by pH of the solution, and that is the reason why you must have pH meter or digital pH meter, because it is determined primarily by pH of the solution. Example, an increase of pH unit from 8, that is alkaline, to 9. Slightly alkaline to 9.0 alkaline increase the amount of unionized ammonia approximately 10 times. Any control of mitigating unionized ammonia and nitrate, and also removal of carbon dioxide. We have dealt with it in the previous slide. If the dissolved oxygen concentration is adequate, adding a source of carbon such as chop hay. You know hay? Hay is formed when you harvest your grasses, legumes, and dry them. You have a hay. So adding a chop hay to your intensive fish pond can reduce ammonia concentration. Many bacteria in fish ponds are starved for organic carbon, and this hay will provide the organic carbon needed by bacteria. despite addition of large amounts of fish, you don't get the carbons you need. Ammonia is toxic to fish if it is allowed to accumulate in fish production system, and that is the reason why you have to change water every 2 days. If you don't have enough water in your house, or after 3 days, change water 100%. When ammonia accumulates to toxic level, fish cannot extract energy from feed efficiently. And if the amount of ammonia concentration get higher enough, the fish will become lethargy, fatigue, and eventually it will fall into coma and die. The farmer will begin screaming, crying. Sublethal effect of ammonia: number 1, reduce growth, poor feed combustion, reduce disease resistance. Impact points on this topic. Unionized ammonia is the toxic form. And it predominates when pH is high, alkaline, 8, 9, 10, 11, 12, 13 to the dead point of alkalinity. Less than 10% of ammonia is in the toxic form when pH is less than 8.0, slightly alkaline. The proportion of ammonia increases as pH increases. Photosynthesis increases pH. During photosynthesis, carbon dioxide is removed from the water to make oxygen, which eventually dissolve in water and becomes dissolved oxygen, and alkalinity will increase. Respiration reduce pH because animal respire it excrete carbon dioxide, especially at night. Amount of ammonia increases as temperature and pH increases. Our next slide is going to be on supplementary feeding. Already you know where to buy pelleted feeds, and you are not used to the increase in price of this feed. You are crying, screaming. Let's see what we can discuss on supplementary feeding practices. There's always a way for us. Subscribe if you are enjoying these topics, these lectures. It is a Black Mind Fishery Studio. Thank you.